So here we have a question from the Pearson IIT Foundation Class 10 Physics. The question belongs to level 3. I prepared a short on it so that this video is being observed. Now I am doing the complete answer to that question. The question is displacement x, variation of a particle with time t is given by this expression. So this is the position vector displacement in time t given by this quadratic expression. We are supposed to find position of the body at time t is equal to 0 seconds and at time t is equal to 6 seconds, and then we have to answer is the particle moving with uniform acceleration. If we say yes, it is moving with uniform acceleration, we have to tell a reason, and if it is in non-uniform acceleration, then also we have to tell a reason. So first let us find displacement of the body at 0 seconds followed by displacement of the body at 6 seconds. So displacement of the body at 0 seconds means wherever you see time, there you plot 0. So if you plot here 0 and 0, this term turns 0. So displacement at 0 seconds is 3 units. I am writing it as 3 meters. Then displacement at time t as 6 seconds is wherever we see time, there we have to put 6. So when you put 6 here, 36. So 36 times minus 15. I just try to work out this. And then 6 times 20 is 120. 120 plus 3 is 123. The product, this product is minus 540 plus 123. So we are subtracting it. So 7. So here 1, here 4. So minus 417. So displacement at the end of 6 seconds is minus 417. Now let us check whether the body was in uniform acceleration or not. For that we have to calculate acceleration. We know that velocity is displacement by time and acceleration is velocity by time. So first we'll find the double derivative of this. First derivative of displacement will give us velocity. Next derivative of velocity will give us acceleration. So how to find first derivative? We'll apply this concept d by dx of x to the power n. So this turns out to be n times x to the power n minus 1. So this philosophy we will apply here. So the first derivative of a displacement, this is called velocity. That means dx by dt is first derivative of this. That means we'll find derivative of this plus this plus this. So d by dt of this plus d by dt of this plus d by dt of this. So d by dt of minus 15 t square is minus 15 times 2 comes forward, t to the power 2 minus 1 means 1 plus d by dt of this is 20, dt by dt is 1, d by dt of constant is 0. So the first derivative of displacement is velocity. Velocity at time t is minus 30 times t plus 20. Now d by dt of velocity is acceleration. So the first derivative of velocity is minus 30 dt by dt, which is 1, plus the first derivative of a constant is 0. So first derivative of velocity, which is this happens to be acceleration at a time t, which is minus 30, and minus 30 is a constant. Acceleration turned out to be a constant. That means acceleration is constant throughout. This means that the body was in uniform acceleration.